All right. So we are now going to turn from long-term memory structure to long-term memory encoding and retrieval. So this is chapter 7, long-term memory encoding and retrieval. And this one, just by random chance, is the cutest lecture that I have. So we are going to see and talk a lot about babies in this one. So we are going to see what the effect is of the fact that babies come in small little packages, that one time in your life you came in a small little package, and the experience of babies in the world and your experience when you were a baby is vastly different than what it is today. So today, if this occurred to you, you would be being caressed and coddled by a 18-foot giant woman. And if this was you today, you would be lifted in the air by a 18-foot giant man. That does not happen anymore. And we're going to see one of the possible implications of that for your memory in terms of, and what it tells us about encoding and retrieval. So we are first going to introduce the antithesis to the long-term memory structure idea, which is the levels of processing theory for memory. And then we're going to take a look at CogLab number 8, your levels of processing CogLab. And then the plan is to then move to encoding specificity and take a look at the CogLab on encoding specificity. And we'll end with a look at what that might explain about infantile amnesia, the fact that you cannot remember entire years of your existence at the beginning of your life, and how this ties into the idea of the self. And we're going to see a very interesting study that somewhat contradicts what they found with Clive Waring, in the sense that your self might be directly tied to your ability to form episodic memories. And we'll see more of that when we get to that study. All right, so first, structural theory of memory. So up until now, the concepts and ideas that we've been working with in terms of memory were these structural theories of memory. And the idea is that the different memory that we have is because different structures in our mind subserve those different types of memory. So memory can be divided into different structures, and we have short-term memory, working memory, and long-term memory, and each of those memories are served by different structures in your mind. So short-term memory has a short-term memory structure. Working memory has a working memory structure. Long-term memory has a long-term memory structure. And if you ask whether an item will be recalled, the answer is that it depends upon the memory structure. So is the item in your long-term memory? Well, then yes, it will be recalled. Is the item in your working memory? Well, then no, it will not be recalled if you get distracted. Is it in your short-term memory? Whether or not it would be recalled is dependent upon the memory structure. So one of the big models, just by way of illustration of this idea about the structural theory of memory, came from Broadbent. And I love his theory, but I also love this photo. This is the most relaxed I think I've ever seen and confident I've ever seen a psychologist look. But Broadbent basically had this very influential structural theory of memory, where he said that you have information, and that information is going into your senses, and then those inputs, that information input gets transferred to different structures. So we have your primary memory, and you can think of this as your working memory. So the S system, this is a really interesting one. This is kind of like the echo that your senses have when you hear something, when you see something, when you touch something. So it's almost like for a very brief period of time, you almost have like an echo in your inner ear, or you almost have a after image in your inner eye. That's what the S system is. And then through that system, it gets transferred into the P system, the primary memory system. And that is like your short-term memory and your working memory. And then if it can get transferred to the final structure, which is your secondary memory, then that is your long-term memory where you can store basically infinite amounts of information. To my knowledge, there has never been anyone that has filled their long-term memory. There has never been anyone who said, you know what, I cannot remember anything else unless I forget something. There's no more room. So again, this secondary memory, this long-term memory seems to be an infinite store. So that's just an overview of that model to give you an idea of that structural idea of memory, different places that your memory goes to, different places that your information goes to, and whether or not an item gets recalled depends upon where is it in this structure of your memory. An opposite theory was proposed back in the 70s, and this is the idea that memory is not divided into different structures, but different types of memory are the result of different levels of processing. So different levels of being encoded, and then different ways that things are retrieved. That is what determines whether or not you recall something. So if you ask somebody in the processing, levels of processing theory of memory, will an item be recalled? They will answer that it depends on the level of processing. So structures, they would argue, are illusory. They don't actually exist. It's a construct or a concept that we came up with to try to explain how our memory works that doesn't actually exist. And the better way to think about it, the new conceptual framework to use is actually a levels of processing framework. So this is from work that was done in the 70s at University of Toronto, where I did my undergraduate and graduate work. And this is by Craik and Lockhart. So by way of argument, that levels of processing might be able to explain how we have long-term memory, how do we have short-term memory, and the features of those memories. They basically put together this table here, and we're just going to take a look at some aspects of this just to make the argument. So the capacity for some of your memory structures, right? And that's air quotes, structures. The capacity for example, short-term memory was said to be small. And the duration was said to be up to about 30 seconds. So experimental psychologists took a look at memory that didn't have a lot of capacity. You couldn't remember a lot of things. So it was a small capacity. And you couldn't remember it for very long. It was only up to 30 seconds. And they said, you know what? That must be a structure. And underlying that structure underlies your short-term memory store. So your short-term memory is kept in this short-term memory structure. And that's why it's small. And that's why it's only up to 30 seconds that you can remember it. And then there are other memories that you have. And these other memories, there seems to be no known limit. You seem to be able to recall as much as you could possibly ever want. And the trace of this, how long you can recall things, are anywhere from minutes to years. So you can recall what you did last week, and you can recall what you did 15 years ago. And their hypothesis, their idea, the structural idea is that, well, this has to be because there's a long-term structure. These memories are in long-term store, and therefore there's no known limit in minutes to years. That's why that memory is being recalled for that long and has that much capacity. What Craik and Lockhart said was that there are other possible features that are confounded with this small up to 30 seconds or no known limit minutes to years features that might be explanatory rather than just coincidental. And what they pointed to was the format of the information and the maintenance of the information. So if you take a look at that short-term memory store column there, where it's a small capacity and it's up to 30 seconds of duration, two other features in there are that short-term memory store maintains its information through rehearsal, and the format of information is phonemic. So it maintains the information through repeating the information And the format of the information would be that auditory rehearsal of the information. So notice that small and up to 30 seconds is associated with rehearsal and phonemic processing. Yep. So in the short-term memory store, the rehearsal is for the maintenance of information. In the long-term memory store, that rehearsal is for the entry of information. And I am not 100% sure in terms of, I would have to look this up, in terms of repetition versus rehearsal, but I would surmise that rehearsal would be the in the moment repeating it mentally to yourself, and repetition would be the viewing of that information again and again and again over time. So rehearsal would be in the moment, and then repetition would be if you saw it the next day and then the next week and then a month from there. All right, so we have rehearsal and we have phonemic as the maintenance and format of information in short-term store. And then in long-term store, we have organization and semantic as the way that information is maintained. So you maintain it by organizing it into structures and tying it into other ideas that you have. And the formatting of that information is largely semantic, largely what something is, information about that thing. So their proposal was that if that's the case, if rehearsal and phonemic is associated with the short-term structure, and organization and largely semantic are associated with the long-term structure, well, then it might just be that there are no structures, and that the only thing that is driving the small and up to 30 seconds versus no known limit in minutes to years is the way that the material is maintained and is the way that the material is formatted. So it has nothing to do with different structures and information going into different structures, and it has everything to do with how that information is first encoded, and then also how that information is stored and retrieved. So we don't need this idea of a structure, and we can say that instead of this primary memory system, what we actually have is we have memories that were encoded with rehearsal and are stored with phonemic information. And instead of a secondary long-term memory system, we have memories that are organized and memories that are largely semantically encoded. So that was the idea, that we don't need structures, we just need different forms of processing in order to explain how it is that we remember some things for very long times and some things for very short times, and how it is that we have a extremely large store for some memories and a really small capacity for other memories. So that was a proposal by Craik and Lockhart. So let's flesh that out. Let's flesh that out a little bit more in some of their assumptions that they put together for this theory. So their big breakthrough idea was the type of processing was actually more important to memory, or was the critical factor in determining whether something would be recalled or not. And they had, I believe, 4 assumptions. Assumption number 1 was that memory is the result of a series of processes. So memory is the result of encoding processes, retrieval processes, storage processes, not where something is stored, but how something is stored. And that these processes form a continuum, and that at the one end of the continuum, that is shallow processing, and shallow processing occurs when you process things like perceptual features of a piece of information. And then that goes all the way to the other side of this continuum, which is deep processing. And one of the highest forms of deep processing is when you process something in terms of its meaning. So memory is the result of these different types of processes. So for example, if I showed you words to remember, and I said to you, rather than try to remember these words, I simply said, count the vowels. I'm going to show you a bunch of words. I would like you to count the vowels. And you go through this one, and you go 1, 2, 3. Elephant has 3 vowels. And you go through this one, you go like 1, 2, 3. Umbrella has 3 vowels. That's shallow processing, because you're just processing the perceptual features of the information. And if I, on the other hand, got you to do semantic processing of this, so I asked you for each of these words that I'm showing you, you need to determine, is this thing alive? You take a look at elephant and you would be like, yes, elephants are living things. And you take a look at umbrella and you would say, no, umbrellas are not living things. And that requires you to access your semantic information. And Craig and Lockhart proposed that that was a deeper form of processing. And basically, the more you need to tie things into stuff that you already know, the deeper the processing is. So one little hack to kind of determine, is this shallow processing or is this deep processing? If you can do the processing in another language, it's typically shallow processing. In a language you don't speak, it's typically shallow processing. If you need to speak the language in order to do the processing, then it's more likely to be deep. So for example, if we were all Spanish speakers here and we did not know any English whatsoever, and I, in Spanish, told you to count these vowels, you would be able to count these vowels, no problem. You would be able to count these vowels, no problem. But if I asked you, is it alive, you might have a really difficult time knowing if elephant is alive, knowing if umbrella is alive, if you don't speak the language. All right, assumption number 2, levels of processing is what determines retention. Not where it's stored, but how is it stored? How did it get in to your memory system? And shallow processing leads to poor retention. That is, it leads to a small capacity and a short-term duration, whereas deep processing leads to better retention. It leads to more information being able to be stored, and it leads to longer retention durations. So again, if I gave you a memory test on elephant and umbrella, and you encoded these with counting the vowels, your performance on that memory test would be much lower than if I gave you a memory test after asking you whether these are alive or not. So the level of processing determines the retention of the information. All right, assumption number 3. Rehearsal actually doesn't directly help memory. So this one is a little bit more of a contentious assumption. So if you don't agree with it, you're not completely alone. But rehearsal doesn't directly help memory, but it does help memory. But they argued that it doesn't directly help memory. And what is happening is that it only helps if it induces a deeper analysis. So this is the idea that it helps indirectly. So if you are trying to remember these words here, and you start going through rehearsal, and you start saying to yourself, elephant and umbrella, elephant and umbrella, elephant and umbrella, elephant and umbrella, that rehearsal will help you recall this information for a longer duration. What Craig and Lockhart are saying is that the only reason it does that isn't because of the rehearsal process, but because you're continually thinking about elephant and umbrella as you say it, you are semantically processing it as well. Because you might say to yourself, well, both of those are great, elephant and umbrella. And both of those exist in rainy climates, elephant and umbrella. And elephant is made of skin, but umbrellas are not. Elephants had ears that can cover somebody in the rain, kind of like an umbrella. So that repeated rehearsal doesn't actually help unless it gets you to think about the items that you are rehearsing. All right, and then the final assumption is the idea that in order to study memory, so if you want to be a researcher that is studying memory, then you need to control the processing. You need to be able to control how your subjects are actually processing the information, because that is the only way to study how memory is encoded, and that is the important aspect of whether something will be retained or not. So they put a lot of emphasis on what they call implicit learning. And I will tell you right now that the implicit learning is not the same as the implicit memory that we were talking about before. And I will show you exactly what they mean in a little bit. But in implicit learning, the subject is basically unaware that the material will be tested later on. So if you are ever honestly, fundamentally surprised by a pop quiz, that means that your performance on that pop quiz is going to be due to implicit learning. You did not know that the material was going to be tested. Now it's being tested, and that learning was implicit. So let's make that very, very clear. And one of the best ways that I found to sort of understand it and really demarcate the differences is to split this up into implicit learning versus explicit learning, and then implicit testing versus explicit testing. So in implicit learning, basically this is your breakdown of any sort of memory test. You have a learning phase, and then you have a testing phase. So the learning phase can be implicit or explicit, and then the testing phase can be implicit or explicit. And again, this is not the same as implicit and explicit memory. I wish they chose different words, but this is implicit learning and implicit testing, explicit learning and explicit testing. So in implicit learning, the subject is unaware that they are learning the material. So in implicit learning, you are listening to something, you are taking in information, but you are not aware that you actually need to recall that information later. You're unaware that you are actually learning the material. This is in contrast to explicit learning. The subject is aware that they're learning the material. So the subject is aware, oh, try to remember these things. This is something that you're going to have to recall later. So most of you in this classroom right now are engaged in explicit learning, because when some of this information pops up on an exam, none of you will be surprised, right? So you're all here saying, you know what, I am aware that I'm learning the material. That's explicit learning. So we have implicit learning, we got explicit learning. Then we have how are you tested? And you can be implicitly tested, where the subject is unaware that they're being tested on the material. And then you can have explicit testing, where the subject is aware that they're being tested on the material. So an explicit test is where that's the one we're more familiar with. That is where you are told, try to remember or try to recall what you saw before. So if I was doing an explicit test here for the words that I used previously in our examples, I would say, does anybody here remember the two words that I used to illustrate Craik and Lockhart's ideas? And hopefully everybody would put up their hand and say, yes, I remember. It was elephant and it was umbrella. That's an explicit test. On the other hand, I can get at your memory using an implicit test by just not asking you to directly recall something, but taking advantage of how memory works, for example, through priming and through spreading activation, which we're going to see later on, to see if you stored the information. So if I asked you something like, name an animal, right now, the first item in your mind is probably elephant, because we have just seen elephant. Now, I'm not asking you to recall what I showed you before. I'm just saying, name any animal. And probably the first word out of your mouth is going to be elephant. That's an implicit way to test to see if you're actually remembering things without saying, try to remember what came before. So keep that in mind as we go through this levels of processing idea. We have implicit learning. You don't know that you're learning the material. We have explicit learning. You are aware that you're learning the material. We have implicit testing. You're unaware that you're being tested on the material. And then we have explicit testing. You are aware that you're being tested on the material. And any combination of those is possible. So you can have implicit learning, implicit testing, implicit learning, explicit testing. That's a pop quiz. Explicit learning, implicit testing, and explicit learning, explicit testing. Explicit learning and explicit testing is your typical, you're going to have an exam on this later on situation. All right, so let's take a look at some of these in action. So we're going to take a look at CogLab number 8, levels of processing. So in this case, in phase one, you saw a word and a judgment. So you were being shown a word and you were asked to make a judgment about the word. And we have three conditions for this. Uppercase, is the word written in uppercase letters? Rhyme, does the word rhyme with another word? Semantic, answer a meaning question about the word. And your task was to simply determine as quickly as you could if the word would fit the judgment. So you would see something like this, and it would say, is the word in uppercase? And in this case, you would say no. This one here, does the word rhyme with park? And you would say no. Is the word a part of the body, cart? And you would say no. So that was phase one. You were just answering questions about the object. Then we had phase number two, where you saw a series of words, and half of those had been shown in phase one, and the other half had not. And your task was to indicate for each word whether it had been shown in phase one. Now, if this was a surprise, then phase two would have been an explicit test, with phase one being an implicit learning situation. So you would have implicit learning, just make judgments about these words, uppercase, rhyming, what's the meaning? And then later on, you're told, hey, you know what? It's a memory test. Boom, try to remember the words that you saw previously. However, in this case, this does not entirely fall into the implicit learning, because the instructions that you received for this was that in phase two, you will be shown a series of words, half of which were shown in phase one and half of which are new words. For each word, please answer the question. So this was in the instructions at the beginning of the COG lab. So if you read these instructions, you now have explicit learning as well. But if you did not read these instructions, then you would have implicit learning. So I guess that depends upon how thorough you were reading through the instructions. All right, independent variable. Regardless of whether you had explicit or implicit learning going on, the independent variable was still the level of processing, and it went anywhere from shallow to medium to deep processing. So shallow processing of perceptual features typically. So the uppercase judgment, is this uppercase or lowercase letters? That was a shallow level of processing. Medium was the rhyme judgment. Does this word rhyme with another word? And then finally, the deepest was the semantic judgment, where you had to make a decision about the meaning of that word. So again, you would have something like, was the word on the list rice? And you would say, no, that one wasn't on the list. Was this word on the list cart? And you would say, yes, I do remember that one being on the list. So what was the impact of how you processed these words initially? What were the results for these three conditions, the uppercase, rhyme, and semantic judgments? So on that x-axis there, we have the different encoding conditions. Did you process it shallowly by by determining whether it was an uppercase word? Did you encode it in a medium level of processing by determining if it rhymes with another word, or did you encode it with a deep level of processing by answering a semantic question? And then on the left side there, we have the proportion correct. And in this case, remember that half of the words were on the list and half of them were not on the list. So 50% is average performance. 50% is your base level of performance. That's what you could expect if you remembered nothing and you were just guessing. If you were Clive Waring doing this study and there was no implicit memory going on whatsoever, 50% would be where you would perform. So let's take a look at how we did. We'll start with the shallow processing condition. And that one is basically just at chance levels. So for all the words where you just determined, is that uppercase or is that lowercase, those words were recalled at a chance rate, indicating that they were very small capacity and very short duration, because by the time phase two came around, those words were absolutely gone. However, the medium processing in the rhyme condition, where we got slightly deeper processing, that proportion recalled increased. So now we've got about 70% recall. And then the most recall occurred with the semantic or deep processing, which was the deepest level of processing. So there we got up to about almost 90%, almost or a vastly better performance than we had in the shallow processing. So you can see here that the ability to recall words, lots of words, and the ability to call them after a long duration was the highest when you were deeply processing these words using semantic questions, and lowest when you were shallowly processing them using those uppercase or lowercase levels. All right, so we kind of discussed some of these, but what kind of learning was occurring in phase one? So what kind of learning was occurring in phase one? Does anybody remember? Implicit. This one, you're right, implicit, or it might have also been explicit. So when would it have been implicit? Exactly. So if you kind of scanned the Cog Lab and just thought to yourself, oh, okay, I kind of get it. It's going to be asking me 3 questions and I'm just going to uppercase, rhyming or semantic. Okay, let's go. Let's start this. And then you get to phase 2 and you're like, wait a second, I got to remember these words. In that case, it would be implicit learning in phase 1. If, on the other hand, you read through the entire thing and you saw that section where it goes, oh, in phase 2, you're going to be asked to recall what you saw in phase 1, then you would have a combination, I guess, of explicit and implicit learning, where the explicit learning would be whatever memory strategies you brought to the table, but the implicit learning would be the processing of the semantic, rhyming, or uppercase, lowercase. All right, what about what kind of testing was occurring in phase 2? Was it explicit or implicit? Were you aware that you were in a memory test in phase 2, or were you unaware? It would be explicit testing. Exactly. So when it finally came to phase 2, they asked you directly, try to remember the words that you saw in phase 1. That's an explicit memory test. Now, they could have done an implicit memory test, and they could have said things like, for each of these words, or for each of these categories, try to come up with a word, and they might say something like a farming implement. And if you said cart first, that's the first thing that came to your mind, that would show implicit learning. If they said something you'd see at the beach and your first answer is boat, that would also show that would be an implicit test to show that you actually had memory for that information. All right, and then finally, according to that levels of processing theory, what kind of processing led to that short-term memory, i.e. the poor performance in this Cog Lab? Which condition had the poorest performance? Well, the short-term memory would have poor performance in phase 2 because it's limited capacity and it's short duration. But which condition, the uppercase, the rhyme, or the semantic, had the worst performance? The uppercase. So the uppercase, determining if it was uppercase, shallow processing just on features of the information, that led to what is short-term memory. So again, this idea that it's not that it got stored in this structure that has short-term implications, is that you processed it shallowly. And if you process it shallowly, that leads to this short-term recall. On the other hand, that semantic information, that leads to long-term recall, and that's why you were way better on the words where you answered semantic questions about them, because those did not go into a long-term memory structure, but rather they were processed in a way that enabled them to be recalled at much longer durations and also to have much more capacity, much more information stored in there. All right, so any questions on CogLab 8? All right, so we're going to introduce the idea of encoding and retrieval and infantile amnesia, but we're not going to get to it today, but I just want to introduce it. I'll put it on your minds so that we can do some processing before we come back next time. So one of the ideas that we're going to have, and we're going to tie it into infantile amnesia, is the idea of encoding specificity. So encoding specificity is the theory that when you encode information, you also encode along with it its context. So when you are learning this information here today, you're not just encoding what's on the slides. You're not just encoding the information that's coming out of my mouth. You're also encoding the fact that you are in this room. You're also encoding the fact that I have a huge projection of the information on the screen. You're also encoding the fact that it's a nice sunny day today. You're encoding the context along with the information that you're trying to encode. So you might be explicitly trying to remember the information that is being communicated to you, but you are also implicitly remembering or implicitly learning all of the context that is coming along with that information. If this is true, if you are encoding context along with the information that you're trying to encode, then encoding specificity says that we should be able to use context as a cue for memory retrieval. So we should be able to take the context, even if it's meaningless, even if it doesn't relate to the information, and we should be able to use it as a cue for memory retrieval. So we actually do have time to do CogLab 9, and that's going to be a really nice setup for the infantile amnesia discussion we'll do next time. So let's dive in. CogLab number 9 on coding specificity. We have phase 1 again, because memory studies typically have those two phases. So in this case, you saw a list of word pairs. So it would be something like car and port. And you would have a first word and a second word. Your first word would be in lowercase letters. Your second word would be in uppercase letters. And then your first word would later on be the cue. And your second word would later on be the target. So you learn car port. And then car later in the experiment would be the cue. And port would be the item that you're trying to remember. So we had two conditions. We had a strong cue condition and a weak cue condition. So sometimes the cue went well with the target, was highly associated with the target. Sometimes the cue, and that would be a strong cue. Sometimes the cue was a weak cue, and it wasn't really strongly associated with the target. So if you had something like eat food, eat is highly associated with food. So that would be an example of a strong cue. If you have something like dry and wet, dry is associated with wet. It's the opposite of wet, but it's still within that same concept of, is there moisture on this particular thing? On the other hand, ones like grasp and baby, not really related. Lots of other words go better with grasp. Lots of other words go better with baby. And then you might have something like lady queen, also very strongly associated. So that was phase 1. You would see those word pairs. And then in phase 2, you would again see a pair of words, one in lowercase, a cue, and one in uppercase. Your task is to judge if the target, the word in uppercase, was shown in phase 1. So in this case, you would be presented with either a strong cue or the weak cue, and your task was to produce the target, determine if it was presented, if it was shown in phase 1. So in this case, we got independent variables. First, we got two independent variables. The first one is the encoding condition. So was the information encoded with a strong cue, or was the information encoded with a weak cue? So when you learned the information, did you learn the target with a strong cue, or did you learn the target with a weak cue? Then we have independent variable number 2, which is the retrieval condition. And when you were trying to retrieve whether or not you saw the word in phase 1, were you given a strong cue to retrieve it, or were you given a weak cue to retrieve it? And then we have this encoding times retrieval conditions, the interaction of these two. So did you learn the information with a strong cue and then try to retrieve it with a strong cue? Or did you learn it with a strong cue and then you tried to retrieve it with a weak cue? Or did you learn it with a weak cue and then try to retrieve it with a strong cue? Or did you learn it with a weak cue and then try to retrieve it with a weak cue? So we have all 4 of those combinations. And again, you would see things like in phase 2, was the uppercase word on the list eat food? So in this case, we encoded this pair with a strong cue. Eat is strongly related to food. And then now we're given that strong cue in order to retrieve it. So this is encoding strong cue, retrieval strong cue. In this case, was the uppercase word on the list cave and wet? In the encoding, we had a very strong cue. It was dry and wet. And now with the retrieval, we're given a weak cue. We're given cave and wet, not something that typically goes together in our minds. We have an example, infant baby. In the encoding, it was a weak cue. It was grasp and baby. In the retrieval, now it's a strong cue. Infant is highly associated with baby. And then finally, lady queen. I thought this was actually a strong cue, but in the information, we'll just go with it being a weak cue. So encoding, it was a weak cue. In retrieval, now you're also presented with the same weak cue. So let's take a look at what we found for the results. So again, we're looking at an interaction here, and the encoding condition that we have here is what was the cue when you learned the material? On the x-axis there, so was it a strong cue when you learned the material, or was it a weak cue when you learned the material? And then on the y-axis there, we have the proportion correct. And this is going to be how you performed in the test phase. The blue bars are going to be the information that was retrieved using a strong cue. Red bars are going to be the information that was retrieved using a weak cue. So not surprisingly, when you encoded the item with a strong cue, and then you were given a strong cue to retrieve it, your performance was extremely good. It was very, very high. So this is encoding with a strong cue and then retrieving with the same strong cue. And then, not very surprisingly, if you encoded with a strong cue, but then you were given a weak cue to try to retrieve that target, we had a decrease in performance, where we had that, again, that strong cue when you encoded it, but a weak cue when you retrieved it. So in this case, we got strong cue. Basically, it looks like it's going to give you better memory. If you're retrieving with a strong cue, you're going to have a better retrieval than you would if you're retrieving with a weak cue. However, that totally depends. The power of the strong cue to help you retrieve completely depends upon what did you encode when you learned the material. What was the context that you encoded the material with? Because if we take a look at the encoding condition where you had a weak cue, where you had something that was not associated very strongly with the item that you were trying to remember, we have this level of performance. So that is encoding with a weak cue and then retrieving with a weak cue. But if you encoded with a weak cue and then you were asked to retrieve with a strong cue, you might think, oh, okay, well, that strong cue is going to help your memory to jog it, to remember those items. But in actuality, it does not. Your performance is actually worse if you learned material with a weak cue and then you're given a strong cue to try to retrieve it. Basically, when you learn with a weak cue, you're better when you're recalling with that same weak cue. And the take-home message here is that as when the best memory occurs is when your cues are actually matching. So the best condition is the strong cue, strong for encoding and retrieval. But surprisingly, the second best condition is using a weak cue to encode and a weak cue to retrieve. So any questions on those results? That one sometimes takes a little bit of time to unpack because we're talking weak cue encode, strong cue retrieve, weak cue retrieve, strong cue encode. There's a lot of moving parts to that. So I will leave you with some questions, and then we'll start up this discussion, or I'll have something to say on these next time. So as we leave today, things to think about. What learning instructions were given in phase 1? Were they explicit or implicit? What testing instructions were given in phase 2? Were they explicit or implicit? And then when I had in-person exams, so I used to do in-person exams when I did all my classes face-to-face, we would have an entire meetings where for an hour and 15 minutes, you would be writing an exam. I don't do those anymore. I don't like them. But when I did in-person exams, I would always, even though everybody had a clock in the back of the room, I would always project a clock on the screen. So why did I project a clock on the screen? We don't answer it now, but think about it. Why did I project a clock on the screen, given the ideas that we talked about today in terms of encoding specificity and hint, I was trying to help out my students. And then next time, we are going to take a look at infantile amnesia, the fact that you cannot remember typically the first 3 years of your life. And we're going to take a look at whether or not encoding specificity can explain that at all. And just to kind of prime your thinking towards that way, think about how vastly different, let's get that video going. Think about how vastly different your life was and your experience of this world was when you were that age. And these giant creatures were walking around, they were saying unintelligible things, and your perceptual experiences were vastly different. Think about when was the last time somebody came and lifted you in the air and you saw the world from that vantage point. And then think about encoding specificity and what we talked about today. And we're going to tie it all in to infantile amnesia. But that is all what we're going to be doing next time. So that's it for what I wanted to cover today. And next time, we're going to continue the cutest lecture that I give in this entire course. But until then, take care.